Alright, welcome back to another terrible episode of Math with Your Teacher. To go ahead and get started, we're going to talk about the greatest common factor. You should have already identified a little bit of need-to-knows with your entry document, and you'll see that we need to know quite a bit about fractions. So in order to do that, you need to talk about first and foremost the greatest common factor. That's where we're going to start. Now, this should be a review for most of you. However, I'm going to show you a way that you've probably not seen before that is quite easy today. You can try that way or you can do it your old way, but you're going to be dealing with some big numbers, so good luck. Alright, your objective for the day is, as a student, you should be able to find the greatest common factor of two numbers. And you're going to need this graphic organizer. It is in the graphic organizer box number 1. You need to get that now. If you need to stop, stop. Hey, pause the video, man. Go get it. Yeah, get it. Put your name on it. Don't forget your name. Seriously, put your name on it. Alright, why do I need to know this? What do I need to know about the greatest common factor? Well, let's be really honest with you. You need it to simplify fractions. We're going to use it when we multiply and divide fractions. And we use it to solve word problems like this one that I got on the screen. Alright, and I want you to let you know a little hint before we get started on these word problem deal things. Alright, it says Sarah has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each colored flower in each bouquet. What is the greatest number? Listen, greatest number. That is an indication that you are going to use the greatest common factor. Alright, just letting you know, you're going to use the greatest common factor. We'll come back to this at the end of the video. However, just wanted to give you a quick hint. Alright, let's get started. So, I told you there's an easy way and there's a hard way. Alright, I don't really care which way you choose, but I'm going to be honest with you, one of them's easier than the other. So, this particular question says, find the greatest common factor of 14 and 42. I'm going to show you the traditional method. This is the way that I kind of believe is hard. What you would have done is you would have listed both numbers, 14 and 42. And then for each of those numbers, you would have listed each of the factors. Now remember, factors are two numbers that are multiplied together to make another number. So in this particular case, two numbers that are multiplied together to make 14. We kind of already did this. Alright, we found the factors of numbers earlier. So 14, what are the factors? Well, 1 and 14. Remember, we don't double up. 2 and 7. What about 3? No. 4. No. 5. Alright, well, 6, no, 7, so we're done. So those are the four factors. Let's look at 42. This is where it gets hard. 1 and 42. 2, well, that would be 21. Let's see, 3. 3, does 3 work? Well, 4 plus 2 is 6, and 3 goes into 6. What is 3? Yeah, that would be 14. Let's see, 6 and 7. Alright, so what's the greatest common factor? Well, then what we would have done is we would have identified the biggest number that is in both lists, and it looks like we've got 14 in both lists, and 14 would have been our GCF of this number. Okay, now it's pretty easy when Mr. Williams does it, but most of us do not know our 14s, even though I'd like you to. And you didn't really know that 3 times 14 equals 42. Let's be honest. Some of you might have, but most of you didn't. So let's show you another way. This is my preferred way. I like this way because I think it's kind of easy. And it kind of goes along with prime factorization in some way when we use the factor tree. It's kind of the same system. Just looks a little different. So what we're going to do is we're going to start with the birthday cake. What we're going to do is we're going to put our first two numbers in our cake. And now this is what we call an upside down birthday cake, which is really important. We need to make sure it's upside down. So we have 14 and we have 42. Alright, so those are my two numbers. What I'm going to do is I'm going to create a layer of my cake. It's just kind of a half layer right now. Alright, it's a little half layer of cake. Oh, there we go. Now, all I have to do is figure out a number that goes into both 14 and 42. What's the number that goes into both 14 and 42? Well, I think 2 does. And so I put that on the outside just like that. And 2 times what gives me 14? Well, that would be 7. And 2 times what gives me 42? Well, that'd be 21. Alright, so you notice right there, all I did was figure out some division. Now, does something go into 7 and 21? Well, yeah, I think I do. I think there's a common factor for both of those. I think 7 goes into both of them. So I'd put 7 on the side of my birthday cake. And how many times does 7 go into 7? Well, 1. And how many times does 7 go into 21? Well, 3 times. And hey, look at that. There's my birthday cake. And 1 and 3. Does anything go into 1 and 3? No, only 1, and we don't ever use 1. So, I guess I'm done. So, where do I get my greatest common factor? Well, that's really easy. You see these two numbers on the outside of your cake? Okay, we got 2 and 7. All we simply do is we multiply those two together. 2 times 7 equals 14. So our greatest common factor equals 14. And that's how we do that. Alright? Real easy. I'm going to show you this 3 more times. On your graphic organizer, you need to write these 3 examples down. Here we go. First one is 15 and 75. Once again, we create our first layer of the cake, 15. 75. Now it's really important that you write these two numbers down in this cake in the same exact order, because later on we're going to use this to simplify fractions, and if you simplify and you don't put them in the order, your fraction's going to be all messed up. So make sure you do that. What goes into 15 and 75? Well, 5. How many times does 5 go into 15? Well, that's 3. How many times does 5 go into 75? Well, let's see. I think that's 15 times. Yep, 15 times. Yep, there we go. Oh, I can make another layer because, well, so a number that goes into 3 and 15, well, that'd be 3. How many 3's go into 3? Well, that'd be 1. How many 3's go into 15? Well, that would be 5. Close my cake off. Does anything go into 1 and 5? No. I know that because I've got a 1 right here, and the only thing that goes into 1 is 1. And hey, and by the way, they're both prime numbers, so there's not a factor anymore. Just letting you know. So what do? Well, I look at the numbers on the side of my cake. I have a 5 and a 3, and what do I do with them? I simply multiply them together. 5 times 3, which, hey, that equals 15. Our greatest common factor for this one is 15. Congratulations. All right, next one, 24 and 36. Same thing. Here we go. Create my birthday cake. Put it right back in the same order, 24, 36. What goes into both? Well, I know 4 goes into 24 and 36. How many times does 4 go into 24? Well, that would be 6. How many times does 4 go into 36? Well, that would be 9. Ooh, 6 and 9. I know 3 goes into both those. Go ahead and make my cake. Put my number on my outside. How many times does 3 go into 6? Well, that's 2. How many times does 3 go into 9? Well, that's 3. Hey, look at that. Those are both prime numbers, so I know that I'm done. My birthday cake is over. I got 2 numbers on the outside, 4 and 3. Well, what goes into 4 and 3? Well, not going to 4. Multiply 4 times 3. You multiply those two together and you get 12. And hey, that's our greatest common factor. Alright, now let's look at the big one. This is where the birthday cake really helps, because a lot of us, we have no idea with the big numbers. And honestly, listing out all the factors for 220 would be absolutely ridiculous. So, this is why we use the birthday cake. So let's go ahead and start. We've got it. Let's get started. We got 40, and we're going to go ahead and put 220. Like I said, the order matters. What goes into 40 and 220? Well, let's just use 10 because that one's easy. How many 10s go into 40? Well, that's 4. How many 10s go into 220? Well, remember the rule, we drop off the 0. That'd just be 22 left over. Alright, 4 and 22. Hey, look at that. What goes into 4 and 22? Well, 2 does. How many 2s are going to 4? 2. How many 2s go into 22? Well, that would be 11. And hey, 2 and 11. Those are both prime numbers, so we just simply multiply the 2 on the side, 10 and 2. 10 times 2 gives us 20, so our greatest common factor equals 20. I like the birthday cake. It helps me a lot. Alright, so that one was pretty easy. Alright, now, you get a chance to do it on your own. Right now, I want you to pause the video. I want you to do these 3 right now. Go ahead, like I told you, pause the video. Actually do them. I'm talking to everybody, all of you, every one of you. Do it now. Alright, pause it. And I'm back. I'm going to go ahead and show you these 3. I want to give you the answers really quickly. I'm going to go quick. 18 and 24. 6 goes into both of those. That would give me 3 and 4. Hey, nothing goes into both of those, so there's only one number on the side. That means your greatest common factor is simply 6. Alright, next one, 15 and 60. 15 and 60. I'm going to go ahead and start with 5. How many times does 5 go into 15? 3. What about 60? Well, that would be 12. Hey, 3 and 12. 3 goes into both those. 1 and 4. Hey, guess what? We're done with those. 5 times 3 gives me 15. Remember, we circle those two and multiply them together. Greatest common factor equals 15. Congratulations. Alright, we've got one more. 30 and 45. And go ahead and start this one. What goes into 30 and 45? Well, I'm going to say 5. How many times does 5 go into 60? Well, that's 6. How many times does 5 go into 45? That's 9. What goes into 6 and 9? Well, 3 does. 3 goes into 6 2 times. 3 goes into 9 3 times. Hey, once again, those are both primes, so we know we're done. 5 and 3, multiply those together. Greatest common factor equals 15 once again. Congratulations. Those are our 3 examples that you should have tried. Hopefully you got them all right. All right, ladies and gentlemen, one last thing before I'm done. All right, there's a word problem. Okay, we talked about this word problem in the beginning of the video. It says, Sarah has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each color flower in each bouquet. What is the greatest number she can make of bouquets? Now, listen, I told you, greatest number. That is an indication that you're going to find the greatest common factor. Seriously, I'll circle it like 20 times. All I'm going to simply do to answer this question is put these both into a birthday cake. 16 and 24. What goes into 16 and 24? Let's start with 4. 4 goes into 16 4 times. Goes into 24 6 times. Hey, 4 and 6, those are both even numbers. I know 2 goes into them. 2 goes into 4 2 times, and it goes into 6 3 times. It's the end of my birthday cake. Hey, look at that. I've got 2 of them. I'm done. 4 times 2 is 8. So my greatest common factor equals 8, which means the greatest number of bouquets she can make is 8 bouquets. Which, if you don't know that, that's just flowers put together. Yeah, buy some for your girlfriend, you mean old kids. Jake Turner, I know somebody who wants one. She'd like a bouquet. Get it to her. Alright, ladies and gentlemen, that's the end of this video. If you need any help, you can either talk to your help desk associate, your human calculator, or you might have to come see me. Just letting you know. Hey, have a great day. See ya.